Hello and welcome to another video. In this video we're going to be doing maximum square area by removing fences from a field. And this is the second problem from the weekly contest for today. And in the problem you have a rectangular field with corners and you have a bunch of horizontal and vertical fences like this. And essentially what you can do is you're asked to return the maximal square field by removing some of these fences. So this outside border has to stay in here, but all of these inside fences are allowed to be removed. And if the answer is too big, return it modulo 10 to the 9 plus 7. So in this first example, what you'd want to remove is you'd want to remove this middle thing, and then you'd want to remove either this or this. So essentially, if we remove this middle thing and this, then we get this square, which is area 4. And in the second example, no matter what you remove, you can't get a square because this is not a square, this is not a square, this is not a square, nothing's a square here. So the way we can do this is we have this example and pretend these are our like fences. Notice that M and N are very big, so they're 10 to the 9th. So we can't just like manually scroll through this, but there are only 600 horizontal and vertical fences. So we can just simply brute force this to get every single combination of width and height possible, because essentially for each one of these, like, how would we do that? Basically, we'd say, like, okay, let's start at this fence and let's calculate the distance here, 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 right? To every single other one, we can calculate that. Then we'll start at this fence. We'll do the same thing here, 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 right? And this is basically I squared. And once we get that, we can have those distances in a set. So we can just have a set of all these distances. And that's pretty straightforward, right? So we'll have a set of distances for vertical. This would be, this would be like the rows, I guess, for rows. And then we can do the same thing the other way, right? So we can say like, okay, let's calculate the distance here, 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 and so on. And we get a set of distances for columns. And then we can simply just iterate through one of them. Like we could say like for all the possible distances in rows, let's just take all of them, see if they're in the columns, and if it's in the columns, let's try to maximize, right? So let's say our set of distances in the rows is like 1, 4, 5, 9, and our set of distances in the other one is like 1, 4, 2, 8. Then basically the 4 is in both of them, and the maximal square would be 16. And so that's essentially, the dimensions are small enough to where we can literally just do like a brute force here. And that's all we have to do. So once you understand the problem and once you know how to do a brute force, what that looks like, then you can do that. So essentially, you can do it in two ways. You can either put these fences in the actual fences array. Notice they're not included. Like if we go back to this problem here, these fences are not included. So you can put them in. Or what you can do is you can manually calculate the distance from the outer fence to all of the inner fences. So if, like, let's say like for this fence, calculate this, 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 right, with a loop, and also calculate the distance from the bottom fence to all of these in that loop. And then simply for every combination of two fences, calculate their distance. And it doesn't even matter where they are. You can just take the absolute value. So like for these, you would calculate their distance. For these, you'd calculate their distance and so on. You're essentially, like, the order doesn't matter at all as long as you get every single combination. And let's just say let's say we're trying to make a square. Like, let's say we remove these two fences and we're trying to get a vertical square. Well, now we know this distance, so we can easily do that, right? So every set of fences you remove that actually gives you a square will give you a distance that you have calculated. Like if I want to remove these two, that's going to be this distance, which I've calculated, right? No matter what, you get it. And so that's basically it. We just make a set for each, and then we just go through one of the sets. So the time complexity here is going to be like h fences squared plus v fences squared. And so now we can go through the code. I wrote it up beforehand. So essentially you have this mod value, you have a set for your rows, and you basically are going to want to add the entire grid first. So you're going to want to add this. So let's say you're calculating like the height. You're going to want to add this distance first. That's m minus 1 because m is 15 here. So m minus 1 is this distance here. And you get m minus 1. then for every single fence, you calculate the distance to the bottom and top fence, right? So you calculate for every single fence, you calculate this, and so on. And then after that, you loop again, and for every single two fences, you just calculate their distance. So now we have a set essentially where our set is going to be all of the vertical distances. Now what I did was I checked if we can use the full square. So I just checked like if this distance is in here and this distance is equal to that, like that's ideal. So it's not even if this distance is in here and this distance is in equal to that. Once we have a set of all the vertical heights, the best possible horizontal height we can get is this whole thing. So I just check like is this whole thing in here? If it is, that's going to be our answer. That's going to be the best square we can make. If not, let's just keep going. And so this is basically repeated code. So like this code and this code is identical, except instead of making another set, I just calculated a column value, and then I check like is this column value in my row? If it is, let's update my result. So basically I only have one set. So the first time I get all the values for the rows, and then when I get the values for the columns, instead of actually storing them, I can just check right away, is it in my rows? And if it is, let's update my result. And then finally, if you did find something, your result is going to be an area. So you can just return it mod. And because I initialized it to -1, you can just return -1 if your result is -1 still. So it's literally just a brute force of like your constraints are small enough. You just want to realize I don't want to go through like M and N. What I really want to go through is this, and this is small enough to pass in just a brute force. You might be able to do something better than brute force, but honestly, I think brute force seems like the only way you can go. I haven't seen anything better yet, so I'm curious about that. And also, funnily enough, when I ran it, I guess this is another way to check. At least no one's done like too much better, because when I run it, it's beats 100%. So I'm assuming if there's like some kind of better solution, it would run significantly faster, so this wouldn't be the case. But we'll see. But yeah, essentially that's another important thing to recognize is this is honestly the main thing to doing these problems is look at the constraints and figure out like what algorithms work, how long does it take, and you want to get really good at figuring out this beforehand. Like you should know, okay, if I want to brute force every single possible height and width, what's the time and space complexity of that? Do I have enough? Can I throw that out and so on? And that's how you do these problems. So yeah, so the time here is, like I said, going to be if height is the height and width is the width, it'll be like height squared plus width squared, right? Because we're essentially looping through all of fences and we're comparing every fence to every other fence, so that's quadratic. And for the space, so the set is going to have every single possible difference. So I think the set is also going to be like height squared, something like that, right? Because we're storing one of them and we're comparing with the other one, so it's going to be something like that. Because let's say all of your fences have a different distance, it would give you something like that, right? Like let's just say you have like n/2 or n/3 fences that are all different distances apart, it would give you all different numbers. So roughly, it's going to be this. Yeah, hopefully this was helpful. I am doing these kind of fast. Like I'm not doing the full code for these because there's a lot of problems, and I am skipping problems that I think are like trivial, and I don't think this one's like trivial. So I skipped the easy one for this contest and just wanted to go through this one. I'll go through the third one and the fourth one as well. So if you like this video, please like it, and thanks for watching, and yeah, see you in the next one.